It's now visible to the naked eye, a black hole discovered just 1,000 light years away from our Earth. We're going to see some supermassive black hole videos from NASA a little bit later on this video. But this black hole discovered just 1,000 light years away from us, visible to our eyes. Astronomers at the European Southern Observatory identified the closest black hole to our solar system yet discovered, and as it turns out, it's been hiding in plain sight and is actually visible to the naked eye, kind of. The black hole in question is 1,000 light years away from our Earth in the Telescopium constellation and forms part of a triple system called HR 6819, which is how the ESO stargazers managed to find it in the first place. They initially tracked the black hole's two companion stars using the 2.2-meter telescope at ESO's La Silla Observatory in Chile, but when poring over the data, it showed that one of the two visible stars in the system orbits an invisible, massive object roughly 4 times the mass of our Sun every 40 days, and that the other star in the pair is located a significant distance away. Petr Hadrava, emeritus scientist at Academy of Science at Czech Republic in Prague, co-author of the research, says, "We were totally surprised when we realized that this is the first stellar system with a black hole that can be seen with the unaided eye. In fact, HR 6819 system can be viewed from the southern hemisphere on a clear, dark night without the need for binoculars or even a telescope. So you have to be in the southern hemisphere to see this with the naked eye." And this is ESO's picture of it. Kindly support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below. In fact, the HR 6819 system viewed from the southern hemisphere on a clear day without the need of binoculars or telescope. What's more, the astronomers believe this could just be the tip of the iceberg and that many similar black holes in our vicinity could be discovered in the future. And in the video coming up, you'll see how they used X-rays to map what are black holes in our universe. It's a new way of doing it. Now, ESO scientist Thomas Rivenius said the system contains the nearest black hole to Earth that we know of. The black hole is what is known as a passive stellar mass black hole and is one of the very few of its kind that we know of that don't violently interact with their surroundings, making them truly black, quote unquote. Now, to date, astronomers have only discovered a few dozen black holes within our galaxy, but most interact rather aggressively with their surroundings, laying waste to all they encounter and emitting powerful X-rays in the process. The silent and invisible HR 6819 that we can see from the southern hemisphere behaves entirely differently, throwing open the possibility that there are many more laid-back, truly black holes out there in our galactic vicinity. Ravinia says, "There must be hundreds of millions of black holes out there, but we know about only very few. Knowing what to look for should put us in a better position to find them." Astronomers are already turning their attention to another system called LB-1, based on their observations of HR 6819. This is from RT on Bended Reality, and also the X-ray echoes mapped to find black holes, disk supermassive black holes. This is a NASA Goddard video, and let's enjoy it together. Please leave your comments. Thank you for your support.
In 2011, NASA's Swift satellite caught an X-ray outburst from a small galaxy 3.8 billion light-years away. Within a couple of days, researchers realized they were witnessing the aftermath of a tidal disruption event, a star ripped apart by the monster black hole at the galaxy's center. Some of the stellar material fell toward the black hole, forming an accretion disk and a jet pointed in our direction.
Tidal disruption events offer us this rare view at the most common kind of supermassive black hole in the universe, these so-called dormant supermassive black holes. 90% of black holes in the universe don't have a lot of hot material orbiting around them. They don't form these accretion disks, and so we can't observe them. Tidal disruption events, where the stellar debris causes the formation of a temporary accretion disk, offers us a way to probe this population of supermassive black holes.
SWIFT monitored the outburst's progress and was joined by the European Space Agency's XMM Newton Observatory and the Japanese Suzaku satellite. Recently, astronomers introduced a new analysis technique that for the first time allows them to peer deep into the gravitational well of a normally quiescent black hole. Called X-ray reverberation mapping, the method charts the region close to the black hole using light echoes from X-ray flashes, similar to the way sonar uses sound to map the ocean floor.
X-ray reverberation mapping has been very successful at probing the accretion flow in well-established accretion disk structures, but had never been used to look at tidal disruption events. My collaborator at the University of Maryland and I were having lunch one day, and she says, "Has anyone ever looked at tidal disruption events with X-ray reverberation mapping?" That night, I stayed late at the office and just tried it out on this data from Swift J1644, and much to my surprise, the result was amazing, and I could see that we were looking at the structure of the inner accretion flow around a normally dormant black hole for the first time. It's not like a normal accretion flow in an active galaxy that's a flat disk. This is something that is extremely puffy, very turbulent, and we are measuring flashes of X-ray emission deep within this newly formed accretion disk.
Stellar material streamed into the developing disk, churning it into a thick, chaotic whirlpool of X-ray emitting gas, funneling toward the central black hole. Deep inside this cavity, multiple X-ray flares erupted, providing a flash that echoed throughout the region.
Previously, astronomers had thought that the X-ray emission is coming from far out in a jet. But what we're finding with these observations is that the X-ray emission is coming from flares very close to the supermassive black hole. And we can use these observations to probe properties of the black hole itself. For instance, we found that the mass of the black hole is something on the order of 1 million times the mass of the Sun.
The first observations of X-ray reverberations from deep inside an accretion disk are providing new insights into a rarely observed class of black holes. They're also laying the groundwork for a better understanding of tidal disruption events and the black holes they illuminate. About 4,400 light-years away, in the constellation Sextans, there is an extraordinary binary system that pairs a rapidly spinning neutron star, or pulsar, with a star about 1/5 the mass of the Sun. Thanks to its rapid rotation and intense magnetic field, the pulsar produces a strong radio signal, which is how astronomers first discovered it. Many similar binaries are known. What's strange about this one is that sometimes the radio beacon just disappears. Then the system lights up in X-rays and gamma rays. Here's what researchers think may be happening. The two stars orbit so closely that gas from the Sun-like star overflows and a stream falls toward the pulsar, but the pulsar produces an outflow of its own. Its spin and magnetic field accelerate charged particles to near the speed of light, creating a high-energy wind. During the radio phase, this pulsar wind easily holds back the gas stream. Now and then, and for reasons as yet unknown, the companion stream surges, pushing close enough to the pulsar that it collects into a disk. Once in the disk, the gas gradually spirals toward the neutron star. At an altitude of about 50 miles, the gas chokes off the pulsar wind, unleashing the full torrent of the companion's gas stream. Gas reaching closest to the neutron star becomes transformed into dual particle jets, which fire out of the disk in opposite directions at nearly light speed. Gamma rays observed by NASA's Fermi satellite may arise along the edge of the jet, while enhanced X-ray emission observed by other spacecraft may come from shockwaves rocking the inner accretion disk. Eventually, and for reasons not understood, the companion's flow ebbs. The pulsar wind again becomes dominant, choking off the flow and blowing away the accretion disk. The pulsar flips back to its radio-emitting mode. Astronomers think this system represents a rare glimpse of a relatively brief phase. Mass transfer from a companion can rejuvenate an old, slow pulsar, spinning it up to tens of thousands of RPM. We may be seeing a system where this phase is on the verge of ending. When it does, the pulsar's wind will erode what's left of its companion until only the pulsar remains. Although astronomers have studied the system in both low and high energy states, they haven't yet observed this transformation in progress. Now, they are watching closely, waiting to document the next dramatic change of this exceptional binary.